We're going to talk about finding measures of central tendency and dispersion in lesson 25. First off, you know most of this stuff. To find our mean, median, mode, and range. You have been doing that for a long time, but let's just go through those really quick. Alright, mean. What you have to do is you have to add all of those numbers together and then divide by the total number that we get there. So 3 plus 6 plus 6 plus 8 plus 9 plus 35 plus 3 plus 6 plus 7 gives us a total of 83. And then we have 1, 2, 3, 4, 5, 6, 7, 8. We have 9 numbers there, so we divide that by 9, and we get a mean of 9.2. For our median, then we need to put these in order from from lowest to highest. So we have, let's see, 7, 8, 9, and 35. And that's all of them. Median is simply the middle number. So there's our 6 there. Mode is most often. We've got 3 6s, so that is that. And our range is our highest number minus our lowest number, which 35 minus 3 is 32. From there, we can also find out if we have an outlier. An outlier is simply a number that is way far away from everybody, all the rest of the other data, that can impact it one way or another. If you look at this, we can see that our outlier is 35 here. Well, if we look at all the data without the 35, our mean would drop to about 6. That would change this drastically. So our 35 had a huge impact on the mean here. Alright, so sometimes when you do this in real life, we throw out the outliers if we can explain them, because maybe it's, there's all sorts of different reasons why you might throw it out, but just to get a good idea of what your numbers look like. Alright, so sometimes we do, sometimes we don't. Sometimes it's important to keep them in there just to see what's going on and kind of compare both sets of data with it and without. From there, we can also make a box and whisker plot. Alright, with that, we have, just as it says, we have a box, and we're going to have a line in the middle of it somewhere, with whiskers going off in one direction or the other. Now, to get our lowest point, that is our smallest number, our 3 right here. To get our highest point, that is our highest number. So that is 35. To get the bar that goes right down the middle of the box, that is our median. Alright, from there, we need to find this first one here, which is called the first quartile score. Alright, to get that, we need to find the median of everything below our first median. So these 4 numbers. Well, the median of those 4 are, well, these 2 are our middle. We have to find the middle of those 2, which makes that 4.5. Well, if we're going to do that on the bottom side, we've got to do it on the top side too. Well, we've got to find the median of these 4. Well, we've got 2 middles. We've got to find the middle of those 2, which is just finding the average of those, which is 8.5. That is really quick how to find your box and whisker plot. We really should draw this more specific to how the numbers are dispersed though, so we have a better idea. If we were to put our 6 right down the middle there, and put our 4.5 over this way just a touch, that is a distance of 1.5 in between there. Well, to go between 6 and 8.5, that's 2.5. So our box needs to be a little bit bigger there. Alright, so maybe something like that. To get our lowest whisker, that's just 1.5 difference between these two. So we need to go the same distance here. So about there would be our whisker for that one. The problem with this one ends up being that 35 would be way over there somewhere. Alright, and that would be what it looks like accurately for something like this. Alright, so mean, median, mode, range, outlier, there's our box and whisker plot. We still have to figure out how to find standard deviation. Now standard deviation is a lot of work, but it's not hard work. Alright, so what we have to do here is to find your standard deviation. First, you've got to find your mean. Alright, well, we simply add up 3 plus 4 plus 5 plus 7 plus 9. And that gives us 28. We've got 5 numbers, so our mean is 5.6. Alright, from there, what we're going to do is we're going to take our mean and subtract each one of those numbers. So, 5.6 minus 3, 5.6 minus 4, 5.6 minus 5, 5.6 minus 7, 5.6 minus 9. For each one of those, we are going to square them. We're going to add them all together. And then we're going to divide by the number that we have here. So we have 5 total ones of them. And we're going to take the square root then. Alright, so finding these individually, we have 5.6 minus 3 is 2.6. 2.6 squared is 6.76 plus 2.56 plus 0.36 plus 1.96 plus 11.56. Alright, that's when you subtract them and you square them. We've still got to add up all of those numbers together and divide by 5. So 6.76 plus 2.56 plus 0.36 plus 1.96 plus 11.56 gives us 23.2. Divide that by 5 and then take the square root, and our standard deviation is 2.15. Now what that tells us, the biggest thing that it tells us for right now is the smaller our standard deviation is, the closer together our numbers are here. Alright, if you were to go back to this previous problem, because most of these are really close to each other, but this 35 is a long ways away from it, we would expect a much larger standard deviation because of that. Alright, so, but when our numbers are all packed together tightly, we can expect a small number. So if we look at this one, we can expect a smaller number again. So going through that, our first step for this last one is to find the mean, which is 14.6. Alright, now to quicken it up a little bit. Alright, it is always the mean minus each one of these numbers. So 14.6 minus 12 is 2.6 squared, plus 14.6 minus 13 is 1.6 squared, plus 14.6 minus 15 would be a negative 0.4 squared, but because this is squared, I'm not going to deal with the minus sign there, because that square would take care of that. 14.6 minus 16 would be 1.4 squared, and 14.6 minus 17 would be 2.4. squared. Alright, and then we would add all those together, divide by 5, and then take the square root. So let's do that really quick. Alright, so 2.6 squared plus 1.6 squared plus 0.4 squared plus 1.4 squared plus 2.4 squared gives us an answer of 17.2. Divide by 5 gives us 3.44. And then taking the square root of that gives us 1.85. So what this tells us is this means, because this is smaller than our previous one, that these are more stacked together than these last ones were. And if you look at that, that's really the case, isn't it? Because 14.6, to get to our lowest, that's 2.6. Alright, well that's the same up here, 3 to 2.6. 17 to that would be 2.4. Well, the difference between these two is 3.4. So that tells you it's a little bit more spread out for the top one than it is the bottom one, and that's why this is a smaller number than the previous one. Alright, that is standard deviation. It is a lot of work, but you can handle this. You just gotta go through the steps. Any questions, please let us know.